Okay, so part two. Hopefully, you learned some stuff from your exploration with part one. Hopefully, you're getting an idea of the relationship between the factors of a quadratic equation and the roots. Remember, the roots are the places where the graph touches the x-axis. Another name for them is called the zeros of the function. Hopefully, you realize that this graph that we're looking at right here has a minimum value because it has, if you look at the graph, it appears to have a bottom. See, it looks almost like a cup shape. And you hopefully, the other thing you realize is that the shape is actually symmetric, which means like a square or a circle or a rectangle, it has, okay, time machine, it has a line that goes through it that you can fold over the shape on itself too. So what we're going to do is there's actually a little formula to find the line of symmetry, and if you also noticed, the line of symmetry needs to be, in this case, a vertical line, which means it has to be written not as y equals mx plus b, because remember that's the equation of a line, but it needs to be written as x equals something. So we're going to go ahead and say that the formula for the line of symmetry is, and you're going to want to make sure you have this formula written down on that very first sheet of this packet with the important formulas and definitions, and you might want to also make sure that you check to have the zeros, roots, vertex, all of those things. Well, you don't know what the vertex is yet. Alright, so x, I don't want those arrows, that's crazy. Go crazy arrows. Okay, I want x equals negative b over 2a. The b and the a come from the standard quadratic form, which is of course ax squared plus bx plus c. So a is the coefficient of x squared, b is the coefficient of x, and then c is the constant. So in this case, in the case of the equation we have right here, f of x is equal to x squared minus 2x minus 7. Our a is going to be the coefficient of x squared. Well, it doesn't look like there's one there, so a lot of people make the mistake of putting just x, but that's not right. There is an understood 1 in front of here. So a is equal to 1, and b is going to be equal to, it's 2, but there's a minus there, so negative 2. Okay. So we're going to go ahead and just plug in our values for a and b into our little line of symmetry formula. So we have x is equal to negative 2, which is of course a negative becomes positive, over 2 times a, which is 2. So what we end up with is 2 over 2, or 1. So our line of symmetry is x equals 1. So we want to just go ahead and graph that in with a dashed line. There's no special reason it's a dashed line, but this is our line of symmetry, and we can write along the side of it x equals 1. So the reason the line of symmetry is very important for us today for graphing is because you'll notice that the line of symmetry goes right through the bottom of the graph right here. This bottom of the graph, if you think of the graph as being, when you watch a graph, it starts from the left and it kind of swoops down through, and it gets all the way down to this point, and this is the lowest point, and then it swoops right back up. So this would be the turning point, the bottom of the graph, or if it were upside down, the top of the graph would be the turning point, or the vertex. Again, you want to make sure you go back and fill in the vocabulary sheet and make sure you know what the vertex is. It's very, very important to know that word and to know that it means that this is the turning point in the graph. All right, so I want to find the location of this point, not just the fact that it goes through, or the line of symmetry x equals 1 goes through it. I want to know the location of this point in space. Now remember, this is a point, so it's going to be in parentheses. I already know the x value is 1 because the line of symmetry that goes through it is 1, and I need to find the y value. So the way to find the y value is really easy. We're just going to take the x value from the line of symmetry and put it back into the original equation. So I'm going to evaluate f of 1 equals 1. Remember, you always replace a replacement variable with parentheses. 1 squared minus 2 times 1 minus 7. 1 squared is, of course, 1, minus 2 times 1 is 2, minus 7. 1 minus 2 is negative 1, and negative 1 minus 7 equals negative 8. And if you actually look and count down these dots, this isn't, the graphing on that little screen isn't the easiest thing in the world because the screen actually isn't square, but you can see you have 1, 2, 3, 4, 5, 6, 7, 8, and that is where our y value is. So this is the vertex. This is the turning point of the graph, negative 1 comma negative 8. So I want you to take a look at these practice problems, and I'll have solutions for them again posted on 24/7.